Urban Innovate Talks with Dr. Henriette Cornet.
Hi, everyone, and hello, Steve. Very nice to have you with us today.
Okay. Hi, Henriette. It's good to talk to you.
Yeah, and so I really want you to introduce yourself and say everything you have done in the field of autonomous vehicles or automated vehicles. We'll come back on this type of terms with you, but just for the listeners so that they know, for me, you are really kind of someone that I've always seen around since I worked in the field and that I think have carried a lot of important work over the years to really help us define and make sure we are all talking about the same thing. And that's exactly what I would love to discuss with you today, because you contributed a lot to the discussions around SAE, the Society of Automotive Engineers, and I would like today to dig into the topic of the levels of automation, because for people familiar with it, we kind of agree, although I'm not sure we always share the same definition, so I'd like to go through that with you. But for other people, it's completely new, so we may need to really explain from the scratch what it is, etc. But before digging into the topic, can you please present yourself and tell us a bit what you did in the past and so far?
All right. I'm one of the long-time people who's been involved with vehicle automation. I actually began when I was a graduate student, which is over 50 years ago, and I did a master's thesis on automatic steering control back in 1973 and a doctoral thesis on automated platooning of vehicles in 1978. And have been working on and off in the field ever since then. I've led a variety of research projects at the University of California at Berkeley. At this point, I'm partially retired from work there, although I continue to do some work. And I've also been active in the technical standards work, both in SAE and in ISO, and actually bringing the SAE and the ISO groups together so that we try to use common terminology and that we're actually talking about the same things. So my work has included developing the technology, testing the technology on full-scale vehicles, giving public demonstrations of the technology, and more recently helping our state of California regulators with technical advice on the development and the implementation of their regulations to govern the testing and the public operation of automated driving systems in California.
You have a very impressive career, because you are also I read you graduate from MIT, correct? So the thesis you mentioned was...
Right, yeah. I spent 10 years at MIT and then spent 11 years working in a Silicon Valley contract research and development company, and then moved to the University of California, Berkeley, when the PATH program got started. And I actually helped get that program up and running in the late 1980s. So, and then have been with the university since 1989.
Impressive. Yeah, thanks for sharing all that. And yeah, I realize you are really the person to talk to with all the work you've done around standards. And I myself have been involved with some standards to very, very small scale in comparison to you when I was working in Singapore. And recently, and it matches with what you said with your work with California regulatory body with so European Commission. The European Commission has updated also, or wants to update all the type approval, homologation, standards that we have, and we need, every time you have the word driver or like some like test that needs to be conducted with a driving wheel, etc. What do we do if we don't have a driving wheel and if we don't have a driver? So I helped them to update all that. So I'm kind of used to the tedious work of standardization and what it means to sit down and read and very, very precise about taxonomy, etc. So I see kind of a shared mindset maybe on this topic. I think we should dig now in the topic of the day, like the levels of automation. So when you meet new people that are absolutely not in the field of autonomous vehicles, that have no idea what it is, that just came to San Francisco for the first time and discovered the Waymo and have never heard about it, and they hear the topic of levels of automation, how would you describe that to someone who has really never heard about autonomous vehicles before?
Yeah. I would generally describe levels of automation as simply the definition of what are the functions that the human performs and what are the functions that the system performs. And what's the division of roles between a human driver and the system in the vehicle, because those can vary widely. And that's just one dimension of the description of any automated driving system. It's of equal importance is the operational design domain for the system, because the operational design domain covers the range of conditions in which the system is designed to actually operate. And the third dimension of that is what transportation service is the system performing? Is it moving people or is it moving goods? Is it doing long-haul trips or is it doing short-haul trips? Is it operating in a fleet environment or is it something that's intended to be used in private personal vehicles? Those are all really different from each other. And it's just as important to understand those distinctions as it is to understand what's the role of the person, what's the role of the technology.
I love the way you put it in such a concise way. But when you say we need to distinguish people and goods, do you mean the levels of the level of automation don't apply the same way if it's for people or goods?
Oh, the levels of automation apply the same way, but I'm thinking in terms of a description of a system. For example, if you wanted to describe a Waymo ride-hailing vehicle or an Aurora truck, they're really different from each other, even though they're operating at the same level of automation. So they're both level 4 systems, but they're dramatically different level 4 systems. They're doing something quite different from each other.
Absolutely. Yeah, I see what you mean. So there is a bigger story than just the levels of automation.
Right. And the reason I emphasize that is sometimes people try to load everything onto the levels of automation and say that all the systems at a particular level are equivalent to each other, and they're not. They can be dramatically different from each other. And the other thing that's also really important to recognize is the levels of automation apply to features in the vehicles. They do not apply to the vehicle. The vehicle does not have a level of automation. It's the feature that's implemented on the vehicle that has a level of automation. And after we go into the levels, then I can explain how an individual vehicle may have different features that operate at different levels of automation in different operational design domains. Same vehicle, but multiple features that do different things in different kinds of conditions.
Yeah, let's go for it. Let's jump into it and tell us more, because I do the shortcut to say this service. So I would maybe speak more about the service. Oh, this is a L4 service, or this is a L2 service. And in my head, it's easier to distinguish what is more like passenger cars or car manufacturer kind of the environment, and those are more like the ride hailing, the fleets. So I do like shortcuts, and I think for the people it's maybe still confusing because they already heard you saying L4 and I mentioned L2. So I think we just need now to go for it and describe the 6 levels of automation, if you don't mind.
Yeah. Well, and actually in the updated version of the document, we're really talking about it as 5 levels of automation, because level 0 is not a level of automation. That's the absence of automation. And then there are really 5 levels of automation. And the other thing to bring up at the beginning is this is automation on a sustained basis, sustained automation of the dynamic driving task. So, for example, an automatic electronic braking system that just might do emergency braking in a hazard situation is not sustained automation, so it doesn't fit within the automation classification. Or a lane-keeping system that will tweak the steering to keep a vehicle from departing from the lane is not a level of automation. A lane centering system, a system that's continuously maintaining the vehicle on the path towards the center of the lane, would be a level 1 driving automation system. But a system that just keeps you from violating lane boundary occasionally would not count as a sustained driving automation.
Okay, not even. Okay.
No, not even level 1. It's because it's not operating on a sustained basis. It only comes into effect intermittently based on, say, a
Like
hazard
the parking,
condition.
when you park, the sound that helps you park your vehicles will also fall outside.
Well, if you're talking about the system that gives you the beep if you're getting too
Yeah.
close to something, that's a warning system. So
Yeah,
the
so it's not even.
the driver is doing all the driving. The system is just giving warnings. So yeah, that's certainly a warning system, but also a forward collision avoidance system, a system that will slam on the brakes if you're about to bump into somebody, is not a driving automation system. That's because it's not doing that function on a sustained basis. It's not changing the division of roles between the driver and the technology in the vehicle. So
Okay.
we just say
That's
that
already,
so a vehicle that might be equipped only with those systems does not have any driving automation.
I see. That's a great clarification to start with, because
Yeah.
indeed I see, and even you see for me, even the warning system, all the kind of the tech that comes in the vehicle and makes the driving easier. For me,
Yeah.
it was like on the path to automation, but you clearly distinguish.
And I think it's okay to think of it as being on the path to automation. It's just that it is not changing the division of roles between what the driver does and what the vehicle does. So the lowest level of automation, which would be level 1, is a system that either controls the longitudinal motion of the vehicle, that's the speed and the separation to vehicles in front, or might control the lateral motion of the vehicle, the position within the lane. So like adaptive cruise control is the most widely used level 1 type of system. It only controls the speed and the separation to the vehicle in front of you. The driver is doing everything else. So it's only taking that small part of the dynamic driving task and doing that instead of the driver. And similarly, a lane centering system, which is controlling the steering, keeping the vehicle centered within the lane, is only taking over that part of the driving task, and the driver is still controlling the speed, and the driver is still controlling the separation to the vehicle in front of him or her. So that's the lowest level of driving automation, because it's only taking that part of the dynamic driving task. So then if we go from level 1 to level 2, that would be a system that covers both the control of the separation between my vehicle and the vehicle in front and controls the lateral motion of the vehicle. But the driver is still doing everything else. And what that means is the driver is looking out for hazards. The driver needs to continuously supervise the operation of the system, because the systems are not intended to operate 100% of the time under 100% of the conditions that you encounter. And those are technological limitations, and they also become economic limitations as well in terms of the cost of implementing the systems. So those are systems that can be of assistance to the driver, but the driver is still doing the driving. He or she is just being assisted by the level 2 driving automation system.
Okay, so to pause here and to recap, level 1 will be either longitudinal or lateral, so to say, but not combined. And level 2 brings like the combination of both.
Right,
if I simplify.
Combination of both. And the really important thing is the driver is still the driver. So, and that's important from the legal perspective as well as from the need for the driver to understand that they still need to be fully engaged in the driving. They can't be looking at their smartphone. They can't be texting or doing those other things, because they need to be continuously paying attention to what's going on in the road environment.
Yeah, and you also say the word legal, which I think is key when you look at what the automotive industry is doing, because at the end, it's a lot about liability in case of accident. But maybe we'll come back to that. Maybe it's going already too much in detail.
We probably need to come back to that a little bit later. But it's also important to recognize that because of the potential for people to misunderstand the limitations of the system, the developers need to incorporate driver monitoring in these systems. And they have to have systems to detect, is the driver actually doing what they're supposed to? Is the driver actually paying attention to what they're supposed to be paying attention to? So that they are prepared to intervene when they need to in order to maintain safe operation. So the earliest sort of least sophisticated systems at level 2 normally did that by trying to detect whether the driver's hands were on the steering wheel or whether the driver was applying torque on the steering wheel. And they used that to try to estimate whether the driver was still engaged. And users pretty quickly figured out that they could trick that type of a driver monitoring system into thinking that they were driving when they really weren't. So, and, there were videos circulating in those earlier years of people strapping beer cans onto the steering wheel so that it would give a torque and would trick the sensor into thinking that they were still steering when they really weren't. So the more modern systems use video cameras and especially infrared video cameras to look at the driver's face and to detect, are the driver's eyes looking forward? Are the driver's eyes open? Has the driver not had their eyes closing? To try to estimate whether the driver is still actively engaged in the driving task. And then normally, if they detect the driver is not doing that, if the driver's looking somewhere else, if they're looking down at something in their lap, at a tablet or at their phone, or going somewhere else, then the system will start giving alerts, and the systems will typically then start slowing the vehicle down and bring the vehicle to a stop if the driver does not remain engaged in the driving task. And now that's a case where some manufacturers have started using this designation, a level 2 plus, to indicate that the drivers don't
to come back to that.
Yeah, which is spurious. It's total bullshit. But we see a lot of people talking about level 2 plus or level 2 plus plus, and that's all rubbish. It's still level 2 because the driver still needs to be paying attention and continuously supervising the system. It's just they've used a different technology. It's a marketing thing, yeah, but they're using a different way of trying to detect whether the driver remains engaged in the driving task. So then they put a plus on it. And it's really misleading.
There was on my list of questions, like the L2 plus that we hear from time to time. I also get when people say that, I know a bit what they mean, but I wanted to have your opinion on it.
Yeah,
I think
but
you
it's just a
clarified. You were very clear on it.
in how the system is monitoring the driver engagement, and it's saying you don't have to have your hands on the wheel for the system to be able to continue operating because it's actually looking to see whether your eyes are in the right place.
Yeah.
And the infrared is really important for that, to be able to deal with things like nighttime conditions where, a normal video camera won't be able to see your eyes, or people wearing sunglasses or different types of eyeglasses that would make it hard to see with visible light whether the driver's eyes are pointing in the right direction, but with infrared, they're in a much better position to be able to detect that.
Interesting.
So,
oh, wow. Okay. I think we got it for level 2.
Okay. So then level 3 is now the big step up from level 2. Level 3 is a situation in which the system is performing the complete dynamic driving task under certain conditions, and it is doing that within conditions where it may need to call on the driver to take over under certain conditions. So level 2, it's up to the driver to monitor continuously and take over whenever there's a problem. When you get to level 3, the system has enough self-diagnosis to know whether it's okay or whether it has a problem. And then when it has a problem, it gives a warning to the driver saying, you need to take over. And you need to take over quickly because the system may not be able to continue doing that driving task for very long after it's run into the problem. So that's a case
you can
where
see the problem here.
well, yes, this is a problem, and it's a really challenging human factors issue, and it's a challenging human-machine interface issue as well. For example, you can't have the driver going to sleep with a level 3 system. And indeed, that's where you also have driver monitoring to make sure that the driver's eyes are still open, that the driver has not fallen asleep. Then you would be in a really unsafe situation when the system needs that driver to intervene. If the driver is not available, now you've got a big problem. But to get to level 3, it's necessary to have a lot of built-in redundancy in the system. The technical requirements on the level 3 system are much higher than they are in a level 2 system because you're not depending on the driver to monitor the system and to look out for unsafe conditions on the road. The initial systems for motorway use were specifically for use in relatively low speeds in dense traffic conditions, so traffic jam assistance, with the idea that if the driver doesn't take over in time, the system can still stop the vehicle and stop the vehicle safely without getting into a hazardous situation that might cause a rear-end crash, for example. And now, as the technology has been improving, the developers are extending the speed range of those systems so they can operate at higher speeds on motorways. They might still typically need to have another vehicle in front of them that they can be following for their longitudinal control. These systems particularly also have pretty elaborate displays within the instrument panel and lights on the steering wheel, other things to try to ensure that when it's necessary to regain the driver's engagement, they can get the driver's attention and get
even
the driver.
With the belt, right? I've heard that you have even system with the seat belt that there will be like system to like or vibration and things like that.
Yeah, and they can use
sure.
haptic signals or vibrate the seat also. That's another very effective way of getting the driver's attention. Put some vibration on the seat, and whatever the driver is doing, that's more likely to get the driver's attention. And each manufacturer has to decide what do they think is the most salient way of getting the driver's attention back when they need to within a matter of a few seconds so that the driver can then resume driving. And they also have to have the countermeasures that if, for example, they detect the driver is falling asleep, they need to be able to stop the vehicle and park the vehicle. And so that you don't get into a situation in which the driver needed to intervene and the driver wasn't able to intervene.
So it's a super tricky level, and I think we should keep also for later, after going through all the level of automation, a little bit of view on the market, because L3 is a bit kind of where the market is not really going, let's say like that.
Yeah, it's at a very dynamic state right now. So, and one of the challenges there, and one of the reasons it is because the advantage for the driver is not that big compared to a level 2 system. Level 4 is a much bigger step in terms of the driver advantage, but it's still expensive to implement it because it requires redundancy in all the sensing capabilities, requires redundancy in the actuation system, and requires this more elaborate user interface. So it's a lot more expensive than level 2, but it's not necessarily that big an advantage for the user compared to level 2. So I don't predict a big future for level 3. But again, it's more of a stepping stone to get towards level 4. And then, so when we get to level 4, now we have a system that does perform the complete dynamic driving task. But the really important thing is that distinguishes it from level 3 is that it can achieve a mitigated risk condition under whatever kind of hazard or fault condition it encounters. And that means that if any bad road condition comes up or any failure on board the vehicle comes up, the system has to be able to bring the vehicle to a safe stop. And with that level of automation, it's now possible to allow the driver to go to sleep, for example, so the driver could actually sleep on a long trip. Or you can have somebody in the vehicle who's not a qualified driver. So that's now the vehicle can be used by people who are, whether they're really young or really old, that people who are not qualified as drivers. And that's what enables the automated ride-hailing services and the trucks that can operate without a driver on board. So that's the big step that enables actual driverless operation, but still within a bounded operational design domain. So, and
The
obviously
conditions, can we summarize a bit? The ODD are more or less the conditions.
Yes, but the ODD is a huge set of conditions for any real system. And again, this is a different SAE standard that's in the ballot right now. There's a standard J3016, which defines the range of ODD attributes. And we'll just tell you that there's a big, the heart of this is a big table that goes on for 20 pages listing the different types of attributes that go into the operational design domain. So those are things like the category of roadway that you're on, the weather conditions, the lighting conditions, the traffic conditions in terms of density of traffic, and what other types of road users do you interact with? Are you only interacting with other motor vehicles, or do you also have to interact with pedestrians and cyclists and people on micromobility devices? And you have to be able to, in fact, for any level 4 system, you have to be able to recognize emergency vehicles and emergency responders and be able to respond correctly to the emergency vehicles and emergency responders. But a comprehensive description of ODD is really quite complicated. And one of the challenges with that is, how do you simplify that to the extent that a normal user can understand what are the limitations in terms of their ability to use the system? The other important thing is that any of these systems need to be able to recognize whether any of their ODD limitations have been violated. So, for example, if they have weather limitations and the weather suddenly changes so that, let's say it's too heavy a rainstorm or the fog has gotten too dense so they don't have sufficient forward visibility, they need to be able to recognize that right away and then go to the mitigated risk condition unless the driver is able to take over and resume the driving task. So again, that will vary depending upon whether there's actually a qualified driver in the driver's seat. But in some cases, a driver might be able to take over to complete the trip. But if there's no driver in the vehicle, then the vehicle is going to have to park itself, or wait for the conditions to change so that then it's able to continue doing the driving.
Yeah, and what might be very easy, like something easy to grasp for the audience, talking of the ODD, and it's only one component of everything you mentioned, is also just the surface of the area that is covered by a service, by a L4 service. And if people go on online or on their app, if they live somewhere where autonomous vehicles are operating, they would see exactly in which area they can book the service. And Zoox, for example, just extend their surface coverage, let's say the geographical coverage. So it doesn't change the road type and many things, but they just go a bit further. And I would say this is a very easy way on one of the parameters within the ODD that is easy to understand, that has something that can expand, so to say.
Yes, and as the technology advances, then the companies can expand their ODDs, not just geographically, but also in terms of things like weather conditions and lighting conditions and traffic conditions. And for example, some ODDs are set up in ways to avoid particularly challenging intersections. So if they have to go from one location to another, they might not take the most direct route because the most direct route might involve an intersection that's maybe too complicated, or might require go through an intersection where they have to make an unprotected left turn. And if they're not proficient with unprotected left turns, then they might go a different route in which they don't have to take an unprotected left turn.
So not everything is visible, so to say. The passenger may not always be aware of all the details of the ODD that you mentioned.
Yeah, they couldn't be aware of all of them because it would be too complicated. But the intermediate step on that is the regulators, who do need to be aware of a lot more of those limitations than, say, a passenger might, but they're still not going to be aware of all of the technological intricacies behind what the manufacturer has developed. So there are challenges in identifying what's the right intermediate level of description of the ODD, because the attributes they're not all independent. They're coupled with each other. And that all makes the actual definition of the ODD technically very complicated. But we should go on to level 5, though, also. And level 5 is now that full automation of the driving task without technological constraints associated with weather conditions or lighting conditions or geography. So the level 5 would be the system that can drive anywhere that humans are capable of driving. So they don't need to be able to drive in a total whiteout blizzards where humans can't drive. They don't need to be able to drive through flooded roads where a human driver would get stuck in the flooded road. But they do need to be able to drive under all of the conditions in which humans are capable of driving.
Okay, but that's very good, that the way you mention it. I really like it, because in my mind, level 5 was always kind of an ideal that kind of even humans are not level 5, like even like normal, let's say, if you're not a pilot, if you're not a professional pilot, there are many conditions under which I would not drive myself. And so I was always thinking of the level 5 being like an unattainable kind of goal for
Well, I say, and I do believe it is an unattainable goal, but it is still bounded by human limitations as well.
Okay.
I mean, again, you can't expect it to operate under total whiteout where there's no visibility in the snow, or super dense fog. Again, think of some of the Thule fog that we get in inland California, where you can barely see the front of your own vehicle, and you can't see
in Singapore
beyond that.
we had this heavy rain. Everybody just stop and you just wait the rain to be over.
So then, so your level 5 vehicle would need to stop as well, because you can't expect it to cover all of those conditions. But I do believe that is an unattainable goal. The reason we defined it, and this is kind of important to bring up, is because when we were first creating this taxonomy with all the different levels, there was a tremendous amount of hype about, automation's going to take over the world. Nobody's going to need to have to drive anymore, and the automation system's going to take you everywhere you want to go. And those of us who are working on this saying, that's not going to happen for the foreseeable future. We need to make a distinction between that vision that has been put out in the general interest media and the reality of the level 4 systems that are being developed and deployed in a variety of different real-world applications. Because the difference between a level 4 system and a level 5 system is bigger than the difference between a level 4 system and a level 1 system. It's because to get to level 5, it would be the combination of all possible level 4 systems. I think that's going to be both technologically and economically unachievable. So the technology is challenging, but the cost of developing it and the cost of proving that it's going to be safe under all of those conditions would not be economically justifiable when you think of all of the very lightly traveled remote areas where it would have to be able to operate. That's not a good recipe for anybody who's trying to commercialize a system.
Yeah, Awesome. Thank you very much for this overview. I think already it helps a lot. I will put some links so that the people see also there are nice charts, nice diagrams that could help understand these different steps. I suggest to move to a bit the market, and we mentioned it just now with the economic value, with the demand. So a way I've been using also the level of automations in my work, and it was to distinguish. So L3 would be in the middle, and kind of, I don't want to say nobody's doing it, because I know BMW has a permit these days on L3 to test it. I don't think it sells that much, but let's look at L2 and L4. Yeah. And so for me, the L2 represents very much the car industry. Also, we did not mention the topic of ADAS, Advanced Driving Assistance System. Is that the same of L2 or L1?
No, and actually that term is a really problematic term. And in the J3016 document, we actually say you should not use the term ADAS because it tries to cover too many different things that are very different from each other. And putting the A in front of it, a lot of what goes in there is not very advanced at all. They're actually pretty basic systems.
Back to my parking warning.
Well, yeah, parking warning, or just sort of really elementary forward collision warning, a system that gives you a beep and flashing light if you're getting too close to the car in front of you. Well, that may have been high-tech 20 years ago, but it's not particularly high-tech.
Yeah, come on,
today.
I did my driving license 20 years ago, and I'm happy when it came out.
Oh yeah, right. Well, yeah. It was high-tech then, but it's not high-tech now. So calling it advanced, I think, is really pretty misleading. Yeah. But the other thing that's really problematic about it is it often is used to include things like level 1 and level 2, which are actually driving automation systems. So I think that there's an important distinction between systems that are doing driving automation and systems that are only warning the driver, or systems that are only intervening in a safety critical situation for a very short period of time. And trying to put all those things together in one basket, I think, is just a recipe for confusion. So I prefer to think about there's a set of warning systems, there's a set of collision avoidance and mitigation systems, and then there are driving automation systems.
In this L1 and L2, let's say L2, where it's kind of more the topic now, we have all the work that the car industry is doing, and I would say probably every car makers are developing these L2 systems. Whereas on the L4 side, we would have more the service, so to say, side. But I think at some point it will merge. But in my head, it was always a bit separated like this, having more the fleet services on the L4, more urban, all these topics of ride-hailing services, shuttles, all these aspects of fleet and shared mobility in terms of shared assets.
Yeah, and I generally agree in terms of them being more fleet operated for a variety of good reasons. But I think the most important L4 applications are actually in trucking. And I think those are more important, they're more economically viable than the passenger services at L4. They have a better business case. So I expect...
Because of driver shortages or cost or wages in general, also of the wages of the drivers.
Well, not only that, but also the benefit to the fleet operator in terms of utilization of their vehicles. So, because of driver hours of service limitations, the drivers can only drive for 11 hours and then they need to take a rest. So if your expensive truck is only being driven 11 hours a day, but with an automated system, it could drive 20 hours a day, you've almost doubled the utilization of that expensive piece of equipment. And you can now get from one coast to the other in the U.S. in 2 days instead of 4 or 5 days. And when people are talking about things like fresh fruits and vegetables, that could be a really big advantage in terms of getting them from one coast to the other in that shorter period of time.
Mm-hmm.
Um, so there's a big economic value to that, which I don't think you have something comparable in the urban ride-hailing market, for example. And one of the interesting things we're seeing in ride-hailing right now is both Uber and Lyft see this as a hybrid market, that
Mm-hmm.
it's going to be a mix of automated and human-driven vehicles, because it would be much too expensive to buy a fleet of automated vehicles big enough to serve the peak period demand.
Yeah.
So they have to size the fleet for long-term demand over many hours of the day, and a lot of the peak is going to have to be served by human drivers anyway.
It matches very much also when I talk to my clients that are like transit agencies, for instance. It's really how I see the future, having this hybrid fleet, and not like we are replacing all your services with a automated driving system. Oh, and by the way, the Land Transport Authority in Singapore, so back to Singapore, is exactly testing now having a bus line, so a regular route, a bus route where during peak hours it's driven by a still a human driver, and during off-peak hours they want to experience with low number of passengers, smaller vehicles, but the same route, same service, etc. And I find it extremely promising, this type of model for the future.
And typically especially thinking of the late night operations, it's a less complicated traffic environment as well. So it's a good way of learning, moving the technology forward rather than trying to deal with the most difficult conditions right from the start. So yeah, there are many good reasons for following that model.
So, every quarter I produce a list of use cases, the different use cases and the different services that exist along everything that we have talked today, starting with L3 kind of car models but you say it's not a car related, but like, let's say vehicles that have L3 features, if I say it correctly now.
Yeah.
And up front with the ride-hailing services, the buses, the shuttles, the truck. What about the delivery robots? Do they fall under different levels of automation, these little robots we see mainly in LA? I saw them.
Yeah, well, and I think it really varies depending upon the class of vehicle that they're on. So if it's for the vehicles that are designed for use on the road rather than on the sidewalks, yeah, they would be under this classification because
it has to be on the road
because it's for road vehicles.
Okay, that's a
but
good
if you have the little, the coolers on wheels, the really little ones that just go on the sidewalks, that's a different class of vehicle that we haven't really tried to extend it to that type of a vehicle.
Yeah. And there will be the drones and etc. Air taxi.
Well,
and
that's a different category as well, because
exactly.
that's now air vehicles rather than road vehicles.
Yeah, it changes. And with everything we have said today, this level of automations, you think they are still highly relevant to be used by the ecosystem, let's say, the community?
Yes, because I think it's important to have some clarity about what is the role of the human and what's the role of the technology. Now, we have to be careful about communicating with the general public, because these levels of automation were never intended as things for communicating with the general public. They were really intended for use within the specialists in the industry and for the industry relative to the regulatory bodies, so that industry and safety regulators can be speaking the same language with each other and be talking about the same things. And of course, that also means lawyers need to get involved in those discussions as well, because that becomes an issue when there's a crash, and who did or did not do what they were supposed to do. Was it the person or was it the technology?
Yeah, and that's exactly where the friction kind of happened between the different players. And if we talk about that, I have to ask you about what do you think? Where is Tesla in this spectrum? I kind of have my way of seeing where it is, but the messaging that they put out, it may be a bit confusing for the public.
Well,
as
they're trying to have it both ways. Yeah, they basically have a level 2 system. They have a system that requires continuous human oversight. They do not have the capability to operate the system without the human oversight. But of course, they've got lots of fanboys who want to be out on the bleeding edge, and they want to communicate with them in a way that makes it seem like they've got something that's more advanced than it really is.
Yeah,
so,
when they brought the topic of robotaxi, I found it a bit confusing because robotaxi is associated with Waymo. Waymo is level 4. So it created a bit of confusion, in my opinion.
Well, that's their business model, is to create confusion. So what you really have to do is look at what's in the owner's manual, which is sort of the more legally binding document. You know, if an incident happens, then people always point to what's in the owner's manual, what's the official communication from the company to the person who bought or leased the vehicle. And that makes it pretty clear it's a level 2 system because that human needs to continuously supervise it. Now, we also refer to them as a level 4 wannabe. Yeah, they certainly want to be level 4, and they've been talking about it for over a decade now. They've been claiming it's imminent for almost a decade, and they're nowhere close to being that. I believe that with the camera-only approach that they've followed, they will not get there. In order to get to level 4, they're really going to have a more comprehensive set of sensors on the vehicle. Yeah. They're going to have a much more robust architecture. And that the way they communicate about what they're doing causes a tremendous amount of confusion and misunderstanding.
That's what I try also in these webinars, in this podcast episodes, to clarify a bit terminology so that it's clearer for the public. I hope some people of the public are listening as well. A last question, and I know is it the standard, the distinction between the word autonomous and automated? And can you say a word about that?
Yeah, the word autonomous should not be used, period. We should strike it from the vocabulary, because the word autonomous means independent and self-sufficient. The word automated is the word that deals with what's the division of roles between a human and a machine. So if you have a machine that is taking over some human functions, that's automation. Now, when we get into the vehicle world, autonomous could be applied to vehicles that don't have any dependence on data that they're getting from other vehicles or from humans. They're operating independently, but that doesn't mean that they're operating automated. So, and this goes back into basically the robotics world, where people first started confounding the two terms. So for years, it's been clear that automation is the substitution of a machine function for a human function. But then in the robotics world, people started talking about, oh, well, now we've got this thing that can operate on its own without having a person involved, so it's autonomous. And that's really a misuse of the terminology. And unfortunately, it sounded fancier, so people thought, okay, all right, that's makes it look like more than what it is. We actually have language in the document saying should not use the term autonomous because it confuses things rather than clarifying things.
Helping. Yeah, thank you. It was great, and I really like you brought light on many topics. I hope it was clear for everybody. We will put resources in the description of the episode. Before ending, I would love you to say a word about this conference, this symposium to which you are heavily involved. I have been involved a little bit in the past,
Yeah.
and I've been following it very closely. I go every year, and I
Yeah.
would recommend everybody to is experts in the field
Yeah.
to join. So tell us a little bit about it.
Yeah, so this is the Automated Transportation Symposium, which will be in San Diego the final week of July. We've had it since the year 2012. The first one was 2012. We didn't even have a name for it in 2012. It was a workshop organized by the Transportation Research Board, and Jane Lappin and I co-chaired that and organized that, and then it grew and grew under the Transportation Research Board. It's now being operated under the SAE International.
Back to SAE.
Yeah, it's SAE, but it's the conferences and meetings side of SAE rather than the standardization side of SAE. And we will have keynote talks by representatives from Zoox and from Uber, and we will have the NHTSA administrator giving a keynote talk, and we will have Seval Oz, who's the incoming Assistant Secretary for Research and Technology in the DOT, giving a keynote talk as well. And we'll have a variety of panel discussion sessions and presentations covering the latest developments in automated driving. So I guess you can post the link for people to check in and look at the program.
And I'm very happy this year. I'm in several sessions contributing from different angles of my work. So I'm very glad to be able to contribute aside of learning from others.
Yeah.
So.
And it's a really nice venue right on the water in San Diego. And with fingers crossed, Waymo may have some service up in San Diego by that time, so people might be able to take Waymo rides. We don't know yet for sure, but
that would be awesome.
That's one of their developing markets. So
fantastic. Okay, so we'll follow that closely, and we'll meet you and me there for sure, and other from the audience. And in any case, we stay connected. Thank you so much for all the insights. And we'll keep in touch. Make sure you come back on Urban Innovate Talks and share more insights.
Right. Okay. All right. Very good talking with you, and hope people found it useful.
Thank you, Steve. Bye-bye.
Okay. Right. Bye.